So today we're going to be talking about the triangle inequality theorem. If I take any three sides, will they make a triangle? Talk to your neighbor. Will any three sides make a triangle?
Oh wait, no.
Put your phones down. Talk to your neighbors about this, please. All right, what do you think? Will any three sides make a triangle? No? Give me an example of where it wouldn't. Do you guys agree that if I've got like 100 units long for this one, and this is 5 and this is 2, please stop the side chatter. If I've got one side length of 100 and a side length of 5 and a side length of 2, those won't make a triangle, will they? These things need to be long enough that they hit, right? And make a triangle. So would 20 and 30 work? Because 20 and 30 would hit over this 100 unit long thing? No, they wouldn't, right? They would end up shy. They only make 50, so they'd fall short. So what has to be true about the two shortest sides to make this a triangle?
80.
They have to add up to more than 100, don't they?
180?
No.
No.
What if they added up to, what if this one was like 60 and this one was 40? It would be a line, wouldn't it? They would fall down. It would not make a triangle. It would just hit together and make two lines together. So what we're going to say here is the triangle inequality says a triangle exists if the sum of the two shorter sides is equal, is greater than the longest side. A triangle exists if the sum of the two shorter sides is greater than the longest side. So in other words, if I want to see if this works, what I'm going to do is take the two shorter sides. Which sides are shorter here? I'm going to say 8 plus 17, and I want to see if that's greater than 24. What is 8 plus 17? Is 25 greater than 24? Yes. Therefore, a triangle exists. Okay, how would I set up number 2? 3 plus 3 is supposed to be greater than 7, is it? No, it's not greater than 7. Would you guys do 3, 4, 5, and 6, please, now yourselves? Go.
Oh, I forgot about that. Yeah, I actually really like.
So I think it's yeah. I don't know. So the
It's a lot of
I don't care. I'm just not really school. I can't form out, but I. That makes sense. Yeah. Good question. That's what I want to get at. Number 5 makes them equal. Does that work or not? No. No, that's just 2 lines. So that's a no. Number 5 is a no. Yeah. Wait. So, why is it? No, 25. I mean, 25. You're shorter. Oh, because what you need is the shorter size. Yeah, they're too short, they fall in. I'm coming by.
I got it, right, like, almost.
Yep.
Yeah.
Figure out if maybe we can make sense size and make it triangle. Because we're working with triangles now, and what if they're like, they don't make it triangle? Wait, 30s, 50, 37. Or, right, like the 2 smaller sides. Size. Yep. And then 37, 42. 52. That's the greater. So look at the percent. Here's your longest side.
Oh.
Right here, flat. Look at it. See your 37 to 42. They'll make a triangle. Because they together and longer.
Okay. All right. Round 2. Please listen up. Finding a range. What if we're just given 2 triangles or 2 edges, sides, and we want to find out if the third side, there's certain numbers that'll work, there's certain numbers that won't work. Somebody give me a number that would work here. 37. It's a great example of one that won't work. Because then these 2 are the shorter ones. 14 plus 22 makes 36. It's not greater than the longest one. So this would not work. 35 would work, wouldn't it? What else? 23. Okay. So this plus this is 36, which is greater than 23. Great. All right. Isn't it everything in between 8 and 36? Boy, that's crazy. How'd you get those numbers? You're right. Where'd you get those from?
Because if you like subtract it, what would you add is the lowest number you add equal for 22, and then the highest you can add the 2, so then you add 14 plus 22, it equals 36.
Does that make sense for you? Or you guys want to hear it a different way? Okay, so let's first assume that this third side is the biggest side. Okay, we're about to find the biggest side. And I'm going to call this A and this B and this one X. It's only going to work if the relationship is what? These two add together to be what?
Greater than X.
Greater than X. So that would work if this one's the biggest side. The other possibility is that we're going to pick one that slips underneath this one. It's not the biggest side. This would be the biggest. And I don't know exactly which of these would be biggest, but let's say that B is the bigger one. That means that we'd also need to have A plus X be greater than B if B is the biggest one, right? We don't know whether X is the biggest one or B is the biggest one. So what I'm going to do is I'm going to position a range. I'm going to say that X is going to fall between two values. This says that X has to be less than these two combined. This says X is less than A plus B. I want to now see what happens when X is greater than something. So I'm going to subtract A from both sides here. I get X is greater than B minus A. So here are my alligators eating X. Here are my alligators eating X. So I'm going to write this as B minus A is less than X.
So could B, but B could be bigger than X, right?
In this second case, B is bigger than X, right? So this is what Bia was saying, is if I take the difference between these two, 22 minus 14, that's 8. And the sum of these two, that's 36. This gives me the range of values that would work. I could do 9, 10, 11, 12, 13, all the way up to 35. I could do 8.1. I could do 35.9. I just can't do 8 or 36. So to find this region, what I would say is X is pinched between 14 plus 22, which is 36, and 22 minus 14, which is 8. That's the range of possible values. So let's do it again here. Watch carefully with my number 10. I'm going to start by putting X in the middle. Let me just finish one more example. X is pinched between two values. The lower value is the difference of these two numbers. 31 minus 28. How much is that? 3. And the bigger of these two values is 31 plus 28. 59. So that's the range of values that would work for this problem. What would 11 look like? X is pinched between two values. What's the lower end going to be?
8.
Good. 11 minus 3 would be 8. And 11 plus 3 would be 14. So that's my region. And I think it's worth putting over here, X be the third side. X is pinched between A plus B and B minus A. I'm going to put those in absolute values because we don't know which one's bigger, really. So please do 12 and 13 and 14 yourselves now.
Always the bigger one, you subtract it from the little one.
If it isn't, then you got the absolute value. Any other questions on finding a range for a third side? Okay, flip this over, please. One more thing to go over. Now, I don't know how you guys were spending your time as kids, but when I was a kid, I used to love cartoons. On Saturday mornings, I'd watch cartoons on TV. And one of my favorite cartoons seemed to revolve around like cavemen. And I am no artist, but let's see how this works out. I picture this cave, and the caveman is like standing in front of his cave, and he's very proud, and he's holding up this stick that he's going to use to kill the water buffalo or whatever. And he's looking out over his savannah and enjoying all the stuff out here. And suddenly out of nowhere, a big dinosaur comes up. And he's about to chomp on this guy. How does he save himself? Exactly, Max. He puts that stick right in between his mouth, right? And the dinosaur's like, arr, 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 and he goes whining away and he's gone. You've seen something like this? Okay. So I use this analogy to talk about the fact that if the dinosaur's mouth is really big, then you need to put a big stick in it. If the dinosaur's mouth is really narrow, then you can only put a little stick in it. And this is called the triangle inequality theorem. It says that if I have a triangle and I tell you that this is 18 and this is 12 and this is 10, I know which is the biggest side. And from that, I should be able to determine what's the biggest angle. Which angle would have to be the biggest? B, because this is the mouth of the dinosaur that gets that big stick stuck in it. Which angle has to be the smallest angle? C, because the stick that goes in it is the smallest side. And this angle A is the mediumest angle, right? It's got the mediumest size stick in it. So the angles of a triangle can be put in order by comparing the sides. The smallest angle is always opposite the smallest side. And the largest angle is always opposite the largest side. So let's take a look at this picture over here. We're going to order the angles from least to greatest. Which is the smallest angle? Good. A is the smallest because it's facing the smallest side. Can you see which is the second? You can? Good. I didn't know you guys all took Spanish. Oh! I said, can you? Okay. Thanks. Thanks very much. Bilingual in our humor here. So angle C is our second. And then what's our largest angle? Biggest side is 13, so B would be our largest angle. The same works for the other way. We can order the sides of the triangle by comparing the angles. The smallest side is always opposite the smallest angle. And the largest side is always opposite the largest angle. Ooh, they threw a little curveball at us. Why? I don't know what F is. Is it smallest, mediumest, or largest?
Small.
How do you know?
180.
Good. So 42 plus F plus 103 equals 180. F plus 145 equals 180. So F equals 35. So this one's 35. So if we're going to label the sides from least to greatest, what's the smallest side going to be? Opposite angle F, right? So the side would be called what? Good. ED. And then what's the mediumest side going to be? DF. And the largest side? FE or EF, right? Okay. Here's what's going on today. This was the last step I'm teaching you today. I'm going to give you the rest of the period to both finish this worksheet up. This will be submitted as homework for today. And we're going to test on this unit today. Oh, I see panic in your eyes. Trust me. I've set it up in Canvas. It's broken out into 4 little mini quiz tests. You can take them as many times as you want. You can use your notes. You can talk to your neighbors. What I ask is that you take this opportunity to make sure you understand these things about triangle centers. Would it be easy for you to cheat on this activity? Yes.
Could you just turn it over and go, Layla, do this for me, here, what's this answer? And have her give me my right answers, I earn 100%, great, I walk away. No smarter for it. And in 4 weeks, what are you guys gonna take?
Final.
The final exam. The final exam will have this content on it. If you walk away today without understanding it, you're gonna have to struggle to learn it later. But if you take these tests yourself, fail them, then look at the answers. Oh, this is what I should have done. Wait, Layla, tell me why I got this wrong. Let her explain it. So then the next time you try it and you get it right, maybe you only get 2 out of 3 right that time. Then you come up to Mr. Erlin, you say, hey, Mr. Erlin, I can't figure out this one about the centroid. I don't know how to do this. Great, I'll look at your past mistake, show you what you should have done, let you try it again and earn that 100%. The goal is to get all 4 of these to 100% today. If you can't get them today, you can stay a little bit lunch to finish it up, but it's gotta be done in front of me. So if you don't finish it today and don't finish it at lunch, that means when you come back from break, you'll have to do it. So I would suggest you do the questions first, and then you can move into the worksheet to finish that up. Okay?
1 second, let me just stop this whole thing.